pound for pound, there is more gold in electronic scrap than there is in ore, right? Just let that sink in for a second. That's from McKinsey, by the way. That phone you're watching this on, or, that tangle of mystery cables sitting in your junk drawer, isn't garbage. It's literally an unmined resource. We're talking highly concentrated, high-yield stuff here. So welcome to The Explainer. I am super excited you're here today because we are completely flipping the script on how we look at waste. We're unpacking the absolute massive economic potential of the circular economy. And look, we're not just talking about saving the planet today, though that's obviously crucial. We're talking about a multi-trillion-dollar shift in global business, going from tossing out trash to harvesting highly valuable terminals. Okay, let's dive into this. Here's our roadmap for today. First, we'll look at the circular economy advantage. Then, supply chains and fast fashion. Third, the e-waste gold mine. And finally, we'll go inside an actual e-waste plant. All right, starting off with Section 1, the circular economy advantage. Trillions on the table. Sustainability usually gets boxed into this purely environmental corner, right? But actually, it's a massive economic engine. A major study found that if Europe just adopted a circular economy approach, they could boost resource productivity by 3% by the year 2030. Now, that efficiency alone, that generates cost savings of 600 billion euros a year. But get this, it unlocks an additional 1.8 trillion euros in other economic benefits. So this isn't just some niche feel-good project. There are literal trillions on the table here just waiting to be capitalized on. And this brilliantly illustrates how industries can actually capture all that value. It's called the Resolute Framework. 6 core circular economy activities: regenerate, share, optimize, loop, virtualize, and exchange. What's actually wild here is that out of 28 different industries they studied, every single one of them can profitably adopt at least 3 or 4 of these activities right now. And 10 of those industries, they could profitably do 5 or 6. From keeping parts in closed loops to totally optimizing supply chains, the pathways to actual profitability are totally mapped out for us. Just so we're all on exactly the same page, let's define what we mean by a circular economy. It's basically using and reusing natural capital as efficiently as possible. It's about finding real, extractable value throughout the entire life cycle of a finished product. So instead of that old linear model, where we take materials, make a thing, and then just chuck it in a landfill, we're actively keeping those materials in closed loops. Make sense? Good. Moving right along to Section 2, supply chains and fast fashion, the hidden impact. Okay, so where exactly is all this old school linear waste piling up right now? Well, we kind of have to look inside our own closets. Fast fashion is basically the textbook example of a linear economy just in absolute overdrive. Between 2000 and 2014, global clothing production literally doubled. And on top of that, the number of garments sold per person shot up by 60%. Plus, making and washing all these clothes uses just an unbelievable amount of water and chemicals. With global consumer spending on the rise, if we don't start making circular improvements, the environmental hit from millions of discarded shirts and pants is going to get severely worse. Now, what's really interesting here is where the bulk of that environmental impact actually lives. Look at this. Supply chains account for a whopping 80% of a consumer business's greenhouse gas emissions. They also make up more than 90% of its impact on air, land, and water. When companies try to go green, they usually just look at their own direct operations, right? The office building, the delivery vans. But the really challenge, and honestly the biggest opportunity for circular solutions, is embedded way deep within those incredibly complex global supply chains. All right, let's zoom in a bit for Section 3, the e-waste gold mine, hazard versus high yield. So the absolute fastest growing segment of waste on the planet right now is electronics. And currently, this massive resource is being, frankly, severely mishandled. See, most e-waste is processed by the informal sector, and that means highly labor-intensive work, super dangerous backyard fires to melt plastics off wires, and really crude extraction techniques that only get you about 30% efficiency. Now, contrast that with the organized sector. We're talking automated or semi-automated plants, totally hazard-free environments, highly efficient mechanical extraction, and a completely safe yield. It's a night-and-day difference. And the absolute urgent need to shift over to that organized sector becomes crystal clear when you look at the toxic effects of informal handling. When you just burn old electronics in open fires, you're releasing incredibly hazardous metals into the air. Lead exposure, that causes brain damage and diminished learning. Cadmium leads to DNA damage and lung cancer. Chromium causes liver damage and fatal ulcers. The informal sector isn't just bad for business. It is a severe, literal, life-threatening public health hazard. Professional recycling isn't just a nice-to-have option here, it's an absolute necessity. And when we do recover this stuff professionally, look at this breakdown. The average composition of old electronic casings proves this isn't junk at all. It is a bundle of highly valuable commodities. You're looking at 30% reusable plastics, 20% ferrous metal, 20% glass, 15% aluminum, and 15% copper. Think about that. Massive amounts of base materials are just sitting right there inside old PC casings, perfectly ready to be looped right back into the manufacturing process. So the really crucial point here is that when we aggregate all this waste and apply advanced tech, the financial payout absolutely multiplies. Specifically for e-waste, if you shift from that basic backyard metal recovery to best-in-class hydrometallurgical recovery, say that 3 times fast, you can extract roughly $5,000 per metric ton. $5,000. That is an incredible margin, and it's created entirely by applying highly organized circular economy principles. Which brings us to Section 4. Inside an e-waste plant, mechanics of recovery. Let's see how this actually works. To truly understand how you pull $5,000 a ton out of old laptops, we need to look at the physical mechanics of an e-waste processing plant. And just to set the stage for how big the business gap is here, get this. Back in 2012, India alone was expected to generate 800,000 tons of e-waste. Yet the functioning organized recycling capacity was only about 100,000 tons. That left a massive, gaping hole in the market for organized businesses to step in, scale up, and turn a serious profit, while simultaneously solving a huge environmental crisis. But scaling up requires a highly methodical workflow. The whole process relies on 6 very precise steps. First, you start with broad collection and aggregation. Get the materials in one place. 2, classification. Step 3 is vital processing. This is where the extremely hazardous stuff like CRT monitors or batteries are specifically routed away to specialized handlers. Step 4 is the manual dismantling of the safe components. Step 5 classifies those newly dismantled parts. And finally, Step 6 is pure mechanical separation. That is exactly how a complex piece of tech, like your smartphone, is methodically broken back down into raw commodities. Let's move to the floor plan and see how this actually builds into a physical space. This generic layout for a Respo's e-waste processing plant takes that abstract circular economy concept and grounds it into a tangible 15,000 square foot industrial reality. You can clearly see the designated areas for unloading, the dismantling zones, the sorting areas, and the specific mill zones. It's like a giant puzzle, but it's an incredibly organized, highly controlled flow of materials. And inside those specific zones, specialized machinery completely replaces those dangerous backyard fires we talked about earlier. We're talking about a completely mechanical, effluent-free process. They use cutting mills specifically designed to chew up circuit boards and wires, reducing the electronics to small pieces. Magnetic separators effortlessly pull out all the ferrous components. Conveyor belts whisk the non-ferrous materials away to fraction separators. And, super importantly, all the automated tasks are conducted in entirely sealed chambers for maximum worker safety. It's clean, it's scalable, and it is highly, highly efficient.
Which brings us to a final thought for you to carry forward today. The next time you upgrade your phone or, you're finally cleaning out that dreaded drawer of old charging cables, I want you to ask yourself, are you just throwing away trash or are you tossing away a literal gold mine? Because the circular economy isn't some far-off future concept. It's already here, and the unseen value all around us is absolutely staggering. Thanks for hanging out with me today. Keep learning, keep questioning, and I'll catch you in the next explainer.